Our daily experience suggests a simple rule. To make something move, you must push it. Stop pushing and it stops. This intuitive view, however, is a 2,000-year-old error, origination with Aristotle. We must break out of this ancient Greek mindset to understand that motion is the natural state of the universe. The key is to realize that the force doesn't maintain motion, it only changes it. For centuries, Aristotle's physics held sway, asserting that the natural state of all objects was to be at rest. His equation was simple: force equals velocity. If the force vanishes, the object stopped. This seems validated when your bike slows to a halt after you stop pedaling. However, Aristotle was misled because he failed to account for a critical, invisible factor present everywhere on Earth: friction. Galileo and Newton shattered that old paradigm by establishing that movement is free. It requires no external force to continue. The fundamental law became force equals change in motion. The core principle is inertia. Imagine an astronaut throwing a ball in the vacuum of deep space. Because of inertia, the ball will travel endlessly, in a straight line at a constant velocity. A force is only needed to change that motion, to speed it up, slow it down, or turn it. On Earth, we see object stops because friction from the air and the ground acts as a constant backward force, actively stealing the object's momentum. The object doesn't stop from a lack of force, but from the presence of a contracting force. This concept is perfectly illustrated by the flat ramp conundrum. A ball rolled down one ramp will rise to its original height on a second identical ramp. If the second ramp is made perfectly horizontal and we assume zero friction, the ball will roll forever. It's perpetually seeking its starting height, a destination it can never reach on a flat plane, ensuring its motion continues indefinitely due to inertia. To truly master motion, instead of asking, "Is it moving?" ask, "Is the velocity changing?" Constant velocity, the net force is zero. Speeding up or slowing down, there is a net force. Changing direction, there is a net force. A car cruising at a steady 16 miles per hour has its engine pushing forward, and air road resisting pushing backward with equal strength. These forces cancel out, resulting in zero net force. The car's motion is maintained by inertia. You only feel a force when you accelerate or brake, because that is when the motion changes. The force doesn't maintain motion, it edits it. Acceleration always follows the direction of the net force. A net force creates acceleration, which is the editor of velocity. An object's acceleration does not have to be in the same direction as its current motion. Example, throwing a ball up. Going up. The ball moves upward, but the net force gravity is down. This downward force causes a downward acceleration, which acts as a brake, slowing the upward motion. The peak. Velocity momentarily hits zero, but the downward force of gravity does not stop. This continuous force immediately initiates the change in direction. Coming down. The force gravity and the motion down are finally aligned. The downward acceleration causes the ball to speed up. Consider a soccer ball kicked into a high arc. The moment it leaves the foot, the only major force is gravity, pulling its discharge down. Why does it keep rising? Because the kick imparted an initial upward velocity. Gravity is fighting its initial momentum. The downward force causes deceleration, slowing down the upward motion, not immediate reversal. Only when gravity cancels out the initial upward speed does the ball stop, change direction, and begin its descent. Force dictates where you are headed next, not necessarily where you are right now. Looking at two equal weights connected over a pulley, common sense suggests they should simply remain at rest. It looks like a perfect tug of war with zero movement. Yet, if they are moving, they will keep moving. Is physics broken, or is your intuition lying? Balanced forces mean no change. This setup illustrates Newton's first law in its purest form. Balanced forces do not mean no motion, they mean no change in motion. In this ideal, frictionless system, the forces cancel out, making the net force zero. If the net force is zero, the acceleration must also be zero. Zero acceleration does not mean the object is stationary. It means its velocity is constant. If the weight starts moving at 1 meter per second, they will remain moving at 1 meter per second indefinitely. Understanding the ideal state of constant velocity under zero net force is a true key to physics. It is what separates those who memorizing formulas from those who understand the universe. Force is not the agent of motion, it is the agent of change.